Welcome to this Orient Lake TMDL presentation. My name is Jeff Burkus. I am the TMDL program lead for the lowaDNR, and I'm going to be joined by Andrew Frana, who is the project lead for Orient Lake. He's going to be giving the bulk of this presentation here in a little bit. A couple of things up top. This presentation is going to be available on our website through August 31st. That is the end of the public notice period. If you've read the TMDL and watched this presentation and have additional comments or concerns about this particular document, you're going to want to have an official public comment sent to me, Jeff Burkus, at that email address there. It's jeff.burkus@dnr.iowa.gov. And you want to have that into me by August 31st. That is the last day of the public comment period. We will gather all of the public comments that we receive during that time period. We will respond to those public comments. We will include those inside of the document before we send that down to EPA. So a little housekeeping up top. So we start off, I just want to introduce a couple of concepts, a couple terms that I think are going to be important for everybody to be on the same page with and understand. And the first one, which is very important to our work, is to understand what a watershed is. And to help us out, I pulled a map from the document. This will going to be available inside of that document for Orient Lake, but this gives a bird's eye view of the watershed of Orient Lake. And how we can tell that is that everything is outlined in a darker outline, and then we've done a nice job of having this be a little bit more clear inside of that dark line, and then outside of it is outside of the watershed. So a good way to think about this is that if it rains, any raindrop that falls within that black border is going to drain into Orient Lake. Anything outside of it is going to go somewhere else. And so this is the entire watershed for Orient Lake inside of that darker line. Outside of it would be a different watershed. And you see it just barely gets some piece of the town of Orient here, and then you have some agricultural lands, which we'll get into. This is a really important base concept for us, and we come back to this again and again, and we use that to help us tell a story on multiple different levels. And I pulled another slide that Andrew will talk more about. You see that same shape outline here, but this time there's a lot of different colors. And so those different colors actually represent the different types of land use. And again, Andrew's going to get into that a little bit more, but important here to every time that you're going to see a map in this presentation, know that that map is going to be in that document that we've referenced that's going to be available on our website. Every map will have a couple of things. It has a compass rose here, so that'll help you orient yourself, no pun intended there, of where north is and east, southwest. And then inset map here, that'll show the state of Iowa, the 99 counties, and it'll show what county we're in here. And then down here is a scale, so you can get an idea of what we're representing here in terms of space. And so anytime you see a map like this, again, it's in that document. Take your time with it, and there's a lot of really good information here. A little bit closer view would be focusing in on the lake. So again, the lake is much smaller than the watershed map, but the lake is outlined here in blue. This is, again, something Andrew's going to be discussing here in a little bit, which is an assessment point. But we try to use maps whenever possible, and there's important information in these legends and keys to make sure that we have a good idea of what they're representing. So take your time with those maps and make sure that you understand what it is that we're trying to get across there. So back to our terminology. Another thing that you're going to hear talked about and written about inside of the document is the word impairment. And an impairment is basically anything that's not meeting water quality expectations. We have these things called water quality standards, and we take a lot of monitoring information as part of our monitoring network. And when we analyze that information, if we're not meeting those expectations, we have this fancy term that's called impairment. And basically all it means is we're just not meeting those water quality expectations. And it's our job in this program to go in and figure out why we aren't meeting those expectations and what we can do to potentially fix that problem. The next terms that you're going to hear, point and non-point source pollution. A lot of people like to think of point source pollution as that you can point to the source. You can say, well, there's a pipe that has that. I find a better, more accurate description of point source pollution is anything that's permitted. So we have an NPDES permit program that allows discharges into waters of our state of different pollutants. You know, so think about a wastewater treatment plant or an industrial facility. That is a more accurate description of what a point source pollutant is. Non-point source is basically everything else. It's a diffuse manner. It's something that comes from overland flow in the watershed, something that you can't necessarily point to, but also it's not permitted. And so those are terms that you'll hear interchangeably. Since we're working in a pretty small watershed, we don't have any point sources, so we're really just focused on non-point sources of pollution here in this particular project. And then TMDL, that's probably the big one. That's in our in our job titles of what that is. And so I have a very specific way of thinking about what is a TMDL. And so I have used this picture for quite a long time. And basically the way that I like to think of what a TMDL is, which stands for total maximum daily load, is that it's a lot like this pack mule here. So at one point, imagine this pack mule with no boxes on this cart. He would be able to drag that cart around the streets, no problem. Very minimal effort to be able to do that. He can do that without any effort. Now, as we start to pack 1 box, 2 box, 3 box, and more, it gets more difficult for that pack mule to be able to drag that cart throughout the streets. Obviously, this is a comical picture where there's so many boxes that he's actually flipped up in the air because it's so heavy. That's not working. And so if we think about our watershed and our lake in a lot of the same ways, if this donkey represents our lake and boxes here represent boxes of pollution, a few boxes of pollution the lake can handle and be just fine and not show any ill effects. But as we continue to put more and more boxes of pollution onto that lake, at some point, it's not going to be easy for that lake to be able to meet the expectations that we expect. And at some point, it's not gonna be able to do anything at all. And so that's the way I like to think of it. In shorthand for that, I just call it the tipping point. And so one of the things that's important to recognize is for us, the TMDL, we will sometimes interchangeably use that term as the document that we're referring to. It is most specifically the number that Andrew's going to talk about, that number of what we have to be able to get the pollutant levels down to for that lake to meet expectations. Now, inside of the document, we will also include what we consider an implementation plan. This is a group of activities that can be done in the watershed, in the lake, land management type activities, and we consider those to be part of the implementation plan. Now, those two things together, that specific number of a total maximum daily load and the implementation plan, those two things add up to a water quality improvement plan. So the overall document that's on the website has the name Water Quality Improvement Plan. So those are the different terms that we have to distinguish between those things. We, and me specifically, will sometimes use TMDL to refer to the document. And so hopefully that doesn't get confusing if we do that, but that's the reason why, and that is that's the description of those different types of terms. And then I just have one last note on any kind of graph that you're going to see. Anytime that it's in the document or Andrew talking about this, again, I pulled this from something that Andrew's going to talk about, and I know that he's going to do a nice job of setting it up. But anytime that you see something like this, know that there is a lot of information happening here. And so take the time, pause the presentation if you need to, rewind it to see it again so that you understand what is happening here. But it's always important to understand what we are trying to measure here on this axis and then on this one as well. So this is time here, and up here we're talking about a certain value. And then all of these points, they're different shapes and colors, they relate to the top row here. And then each of these points is a measurement. And so my overall message to you and plea to you is to just take your time and make sure that this makes some amount of sense, because there's a lot of information packed on here, and it's important to be able to understand the overall point of what Andrew is going to be talking about is to really understand what the background is of each of these slides. So feel free to pause and rewind. So that's it for me. I'm going to turn it over to Andrew Frana, who's the project lead for this, and he is going to take you through the specifics of Orient Lake.
Thanks for that introduction, Jeff. As he said, my name is Andrew Frana, and I will be talking about the TMDL for Orient Lake. I want to start out with an outline of what we'll be talking about. Jeff did a good job of describing what a water quality improvement plan is, but I will go a little bit further. From there, we will talk about the description of Orient Lake and its watershed. We now know what watershed means. Then we will talk about the water quality assessment of Orient Lake. From there, we will use those values to determine a TMDL. We all know what that is now, too. And then we'll talk about implementation planning and what we can do to improve the water quality of Orient Lake. So parts of the water quality improvement plan. First of all, we have to monitor and assess the water body. That actually requires that we get out on a boat and take samples and send them to a lab for analysis. If the water quality is determined to be impaired, we will draft a water quality improvement plan. Parts of that include the potential pollutant sources, where are the issues for the water quality coming from within the watershed. Then we will calculate the total maximum daily load for the lake. And from there, we will have a implementation plan provided with a list of solutions and best management practices and things that may hopefully improve the water quality. After that, we'll have a public meeting just like this, asking for review and comment. And then we will go to local involvement, led by interested parties in the watershed. And from there, we also have to continue monitoring the water body to assess if the water quality has improved or not. So let's just dive in. Lake Orient is located in Adair County. Here's some fast facts about it, when it was constructed, the depths and things like that. The area is 26.1 acres. And for those of you that may not be familiar with the term, an acre is about the size of a football field. So if you can imagine 26 football fields is about the size of the surface area of the lake. The Orient Lake watershed is 613 acres directly next to the city of Orient and in Adair County. The land use of the Orient Lake watershed has several features. One that pops out is this yellow and brown crosshatching. That is row crop formations in the watershed compared to the green area around the lake, which is forest and park ground. If we look at the percentages, row crop is over 75%, while grassland is 8 and all others are 17. So we might see that row crop has more of an influence on the water quality of Orient Lake than others. Next up, if you look at the soil type map, we can see several different types of soils with the legend here clarifying if they're Clorinda, Clearfield, Laboni, and others. Some takeaways would be that is less formed over till, and that makes it a little bit more susceptible to erosion than other soil types around the state. If we look at the slope distribution of the watershed, which talks about how flat or how steep the hills are inside the watershed, we can see that 80% of the watershed is either flat to moderately sloped, while there are small areas of rather steep side hill slopes, which could indicate terrace formations inside the watershed. So those will be something that we'll want to take care of and look at inside the document. Now we're going to talk about the assessment of Orient Lake, what is wrong with Orient Lake, and to not bury the lead, there are water quality issues from algae and sediment, which can cause pH issues as well. And we'll talk about those a little bit more in depth and talk about where they come from. This map came earlier with Jeff. This is the data collection site, or where we gather our water quality samples. You can see that it is near the spillway, this little location here. And what we do is we'll test for nutrients and water clarity at this point. every time we collect. So every time we go out there, we'll collect at the same point to be consistent. So now we go from talking about the lake itself, the watershed, and the different characteristics of the watershed. We can go into talking about the water quality analysis of the lake. Next up is the water quality analysis for the lake. And we talk about that. We want to figure out what defines poor water clarity. It can be a couple different things. It can be either too green from algae-based issues, or too murky from turbidity issues, or if you want to think of turbidity as suspended sediment or small soil particles floating in the water column. And what we see in Orient Lake is at any time it can either be too green, like a split pea soup, or too murky, like chocolate milk. So depending on different issues and factors in the watershed, the water quality can change throughout the year. What we see in this bottom picture is a environmental engineer using what we call a Secchi disc to measure the water clarity. And on the right here, we can see the disc itself consists of black and white alternating quadrants attached to a rope that can be used to measure the transparency of the water. So as they lower it down, once you cannot tell the difference between the black and the white, that depth is marked and noted, and that is what we call the Secchi depth. The farther down you can see, obviously, the clearer the water. If you can't see it up here, then that would indicate lower water clarity. I'm going to set this up. Jeff did a good job talking about graphs and charts and things. I'm just going to set this up from the beginning. We are going to be talking about trophic state indice values. But first of all, on the bottom axis, we have the year. So these years from 2002 to 2016 indicate the assessment period for the water quality analysis of Orient Lake. So we have 14 years of data here that we're going to be including. The vertical axis, or the y-axis, are those trophic state index values that just measure different productivity levels of different factors that we'll be looking at. And the main important thing right here in this slide is this value of 65. So we talked about what impairment is and what that means for the lake. Any values above this impairment limit of 65 TSI are going to be an issue for the water quality of Orient Lake. Anything below 65, we're in the clear, no pun intended. So the next slide shows these annual values of different factors in Orient Lake. 3 different measures we're looking at up here. We're looking at Secchi. So Secchi is that Secchi depth that we just talked about. The larger the Secchi value on this chart indicates the shorter the depth of water clarity in the lake. So higher values of these blue diamonds indicate poorer water quality and poorer water transparency. Next up, we have these green triangles, which is a TSI for chlorophyll A. Now, chlorophyll is a stand-in here for algae production. So just think of the green triangles as little pieces of algae instead of the scientific chlorophyll A. So the more amount of algae in the lake, the higher these green triangles. And we can see that throughout the assessment period, these green triangles and these blue diamonds consistently appear above this 65 limit of TSI values that would indicate an impairment. And finally, we have these purple squares that indicate measurements of total phosphorus. So if you think of the algae needing nutrients to grow, much like a cornfield, this total phosphorus can help the growth of the algae. So when we measure phosphorus in the lake, we can see that there is an abundance of phosphorus throughout the assessment period over that 65 limit the entire time. So these values as a whole indicate that there are water clarity and water quality issues in Orient Lake stemming to the impairment of the water body. A bonus of this Orient Lake is the chlorophyll A, or the algae, can also have pH issues in the lake. So if you go back to some, middle school science, pH is the measure of how basic or how acidic things are in a solution. And we see that the pH values being above 7 neutral, they're about 9-ish the majority of time. That can cause issues for aquatic life, that can cause issues for fish, amphibians, things like that, that want a consistent pH value. So when it fluctuates like this throughout the year, that can cause issues and have an impairment for aquatic life as well then. So we talked about the water quality analysis. Now we can dive into the TMDL itself. Jeff did a great job with his analogy of the pack mule and the cart. Just to revisit it, it identifies the maximum amount of a pollutant that a body of water can assimilate while still meeting water quality standards or not being impaired. So the TMDL has 3 main things before the value. It has a target, what are we looking for, the equation itself, and then an allocation of where do those little pieces of the equation go to. So in this case, if we remember from that chart, there is an abundance of phosphorus in the lake, and the document describes in more detail why our target is phosphorus. But generally, phosphorus can cause an excess of algae. If there's a lot of nutrient for the algae will grow more. And it can also cause cloudy water, because phosphorus in many cases tends to be bound to sediment that is eroded to the lake, and that can be transported by either surface runoff or groundwater flow. So the target is phosphorus, and what we're going to want to do is reduce sediment from runoff into the lake. So we have our target. What are sources of that target of phosphorus? Jeff did a good job of also explaining there are 2 different types, point sources and non-point sources. If we look at point sources or potential point sources in the lake watershed, there are none. There are several different types, wastewater treatment plants and direct outlets, something that you can point at or something that is permitted. So we don't have to worry about point sources in this watershed. If we look at non-point sources, they're pretty much anything else that isn't a point source. Those can be several different things, land application of fertilizer and runoff from row crops, grazing animals, wildlife, urban runoff, failing septic tanks on farmsteads, or stream bank erosion closer to the lake itself. And we'll see that land application of fertilizer and runoff in the document is one of the major contributors of non-point source pollution to the lake. So we have our target of phosphorus. Now we're going to talk about an equation. And what we have here is the TMDL equation, or it's the main payoff of the document. So when we look at the TMDL, it consists of 3 different things: the summation of the waste load allocation, and the load allocation, and what we call a margin of safety. So the waste load allocation is the equivalent of the point source pollution in the watershed, which we talked about is 0. There's no contributing phosphorus from point sources. The load allocation would be everything else, everything that's not point sources, so non-point source pollution. The load allocation of total phosphorus is 270.9 pounds per year. And then we tack on what we have as a 10% margin of safety, which in this case is 30.1 pounds of total phosphorus per year. We have that margin of safety just to make sure that if any of our calculations are off, we want to make sure that we're conservative with those values, so we have a little bit of room for error. So the total TMDL, or the total maximum daily load of phosphorus for Orient Lake, is 301 pounds per year. If we look at the existing load of phosphorus over that 14-year period, the average is 942 pounds of phosphorus per year. When we compare that to the total maximum daily load of 301 pounds per year, we see that we're going to have a 68% reduction in order to meet our goal of what that pack horse can have on the cart and still travel around the market. So we want to have a 68% reduction of total phosphorus to get to our goal. So we have our target, we have our equation. That's useful for the document itself, but if we allocate that, then it'll be useful for stakeholders in the watershed. So if you look at allocations of total phosphorus contribution to Orient Lake, we see that nearly 72% of it comes from row crop, with smaller contributors from grassland and urban contributions as well. But the main point here is that row crop has nearly 72% of the total phosphorus contributions to the lake. So we really want to pay attention to how we can lower that and get the most bang for our buck when we talk about implementation planning and best management practices. Next up, implementation planning. So when we talk about implementation planning, we just want to think about the best possible solutions to reduce phosphorus in Orient Lake in this case. And in order to be successful, we really want to encourage local participation, and then also to quantify or see how we're doing water quality wise, we want to allow for future monitoring and future analysis. So if you talk about some of these best management practice scenarios, the first one that we want to talk about is land management or prevention. We want to see if we can stop phosphorus from even leaving the soil on its way to the lake. And one added benefit is that it can improve both soil and water quality. Some examples of ways we can prevent phosphorus loss is conservation tillage, no-till, cover crops, perennial strips, and manure management. So the thing that these all have in common is these practices will try to stop phosphorus or erosion or things like that from even starting. So we want to stop it before it begins, because it's a little bit easier once things start moving. And here's an example of a land management, best management practice with no-till farming. We can see that this is soybeans planted over corn from the previous year. The leftover corn stubble can reduce rain energy as that drop comes down and can slow or eliminate soil detachment from the surface, which can reduce erosion, which in turn would reduce phosphorus contribution to our lake. Next up, we can talk about structural or mitigation practices, which would intercept and trap pollutants during transport. So once that phosphorus starts moving on its way to the lake, what can we do to stop it and maybe reduce the energy and not get it to the lake? Some examples of that would be buffer strips, either riparian or saturated, grass waterways, sediment basins, and wetlands. And what all of these things have in common are once that runoff and once that erosion starts moving, we're going to try to slow it down or reduce the energy in it so that suspended sediment and that phosphorus falls out of solution. So we want to try to slow the water down on the way to the lake. The longer it takes to get to the lake, the more sediment and phosphorus we may be able to remove. An example of that would be sediment basins. This is a picture from somewhere in Iowa. We can see that it's doing its job by detaining the water, and as that energy in the water slows down, we can see soil particles fall out of solution and create these pockets of sediment. We'd rather have it there than in the lake. We don't want it at all, but we'd rather have it there than in the lake, contributing to poor water clarity. And finally, we have in-lake best management practices or remediation, and those can fix existing issues in the lake. So if we already have water quality issues, these might be some practices that we can look to. Some examples would be fisheries management, shoreline stabilization, or targeted dredging. And in this case, we might want to look at, and it's described further in the document, fisheries management over other more expensive practices like targeted dredging or shoreline stabilization. So fisheries management, what that means is we could look at some of the rough fish populations like grass carp and other things, and maybe reduce or eliminate those. They can, as they're feeding on the bottom of the lake, stir up sediment, resuspend that, and then cause further water clarity issues. So that can be one of the best management practices in this in this lake. Some of the next steps after that, we always want to talk about continued monitoring. So after we put those best management practices in, we want to see how effective they are. So we'll have to continue to monitor to see if where we're getting our most bang for our buck. Are we seeing improvements from prevention strategies, from mitigation strategies, or what? And always, to be successful, we want to have a locally led effort. The more people involved, more people on the ground in the watershed, the higher the chance of success we're going to have. And some of the things that we can do are promote awareness, create a watershed group, and use this water quality improvement plan. And further, the DNR may be able to assist with technical issues with these best management practices and design. But from there, I'm going to kick it back to Jeff just to round things out. Thank you for listening.
Thanks, Andrew. Great job. The only thing that needs to be said is reiterating the point that if you have an official public comment that you would like to have addressed and be included in the document, make sure you send me that comment by August 31st, again, at that email address that's listed there. If you have technical questions that you would like answered, feel free to reach out to Andrew. He's a wealth of knowledge, and he can be found at his email address, andrew.frana@dnr.iowa.gov. You also have our phone numbers there in case you want to give us a call. But otherwise, thank you so much for viewing this video, and let us know if you have any questions.